So, deep first search is a very good search algorithm, I would say myself, because it explores the deepest parts of a node until it needs to come back. If it does not find the solution, till it needs to come back and explore again. It's very easy to think. Like I like the example I actually used last time of explore. So exploring a cave that has a lot of ramifications. He goes until he sees, for example, one of these ramifications, and then he chooses one path, and then he goes another, goes and goes and goes until he finds, well, the beloved treasure room. My B in the last example, of course. But, well, there are two main problems. Well, the first one being, if the number of rooms are infinite, then, well, it could possibly, again, because it's random, we didn't choose exactly. For example, it has an option to go left, right. We didn't, well, they haven't put any code that says should have preference to the right or to the left. So by chance he could find the treasure room, might be, or he could, well, fall into a abyss, which would be finding one of the branches that are infinite, which, believe it or not, some cases are. I'm not sure which ones, but mm, I think, for example, actually I don't have exactly an idea of what infinite cases would be. But, well, this could be a video topic next time. But today we're not talking here about deep first, but, well, we did it last time. So you want to check it out again? Check my playlist. These videos should be on a playlist now. So if you want to see it, uh, boom, it should appear here now, or I think here left. So you could check out what exactly we are comparing this method breadth first for deep first. So how breadth first works? Well, breadth first is, well, a search algorithm that always expands the shallows known in frontier, that uses the Q method of, well, the frontier. Pretty much it spreads like moss, and I'm not meaning speed, even though moss spreads in actual incredible speed if you think plant terms, but on the method, or better yet, pretty much almost the lack of one. Let me explain. Deep first search, again, could randomly choose right or, well, left. Depth breadth first would do something like this. Would, for example, let's say go right, but do also go left, and he will slowly expand until he finds B. So it's very different indeed, because it will pretty much two by will slowly expand again. It will expand the further to the nearest to the node, to the point where we are. So A. So the one closest, then the second closest, then the third closest, fourth closest, fifth closest, until I think sixth closest. This. And also, again, we are not choosing between right or left. For example, here you could have one that goes to the right as well. You could go one that goes to the up. So we haven't changed that. But that's pretty much how we're going to expand. So you can see here the number of choices here are about the same, as you can see, but very interesting that we created two different paths, one that leads us nowhere and one that leads us to the goal, which is B. So, well, how would this method compare against deep first, or better, not even compare, how it would solve this puzzle? Well, again, this is very interesting, and, well, you will see what it's talking about. First, it will slowly creep its way until a decision. It does not differs how it actually chooses a frontier. Sorry, chooses between frontiers is the change. But if we have only one path, it will do the same thing. Just go until it finds well a path, but from differentiation here. So well, a separation. The interesting thing is that deep first choose, for example, left one, and you explore absolutely everything of the left one, absolutely all the nodes, until it explores, it sees there's nothing leading to B, and then it goes back. But that's not how breadth first works. It may start going left, but then it starts going right, and you will slowly feel everything absolutely one by one. And you can see here, especially here, a very interesting way of how it spreads. Here we have, again, we find ourselves here. It will spread, for example, left, then right, and will be on this type of movement. Left, right, left, right. When it finds itself here, left again, it will feel right again. Then it might choose, for example, let's say left, left, or left, right. It might choose left, right, then left, left, then right, or case up pretty much. So left, right, left, left, right, left, right, left, left. Then, since everything's filled out, it will not expand anymore, but it will keep going right down. Then, when it finds itself again in a situation where it needs to choose between one or two paths, it will pretty much choose both, going maybe right and down, and you slowly feel absolutely everything. You can see which will eventually lead to the conclusion. In this case, our conclusion, well, well, it did feel absolutely everything. Now, it's a very interesting case, the breath first, because while its solution it might not, uh, well, you can see be the fastest. After all, I absolutely did every single move I could. It's also the optimal solution. Now, hear me out. Inside my solution, it should be a little better. It's the optimal solution inside it. So, for example, here, uh, in this case, my optimal solution would be going like this. And since I fill out everything in this puzzle, so inside my solution, which is all my moves, which is, well, literally every move I could do, inside it, it's the optional solution. Now, this could have, for example, a type of thing to filter it out, but not always. Now, it's very interesting how breakfast works because it might choose again. Breakfast might be more, in case it is more energy or resource intensive, since deep first it will focus on only one branch or only one branch of nodes and expand it the farthest it can, and then it will, well, go back. In this case, breath first will slowly rise like an ocean on a morning, or, well, for example, sorry, ocean at night, or you pouring liquid in a cup of glass or a cup of, you know, uh, sandbox. It will slowly rise, pretty much, or in a cavern if you think about it. But breakfast is very interesting because technically, given enough time, it could find a solution even on a infinite number of paths, since there is no way you can find a solution in the infinite part. There is an infinite moves to find the solution. It will, since it will always spread the farthest you can, you spread absolutely every single node at the same time, almost, it will eventually find the solution. Unlike deep first, which perhaps might be faster if there is a finite number of choices. If it's an infinite number of choices, then you are pretty much flipping the coin of either getting the solution or just don't getting nothing in your artificial intelligence exploring a infinite path. So it's very interesting to think about the differences. But well, that's it for today. If you are interested in more and you want to understand what I'm talking about deep first, well, you can see my last videos. In case my last videos had exactly that. And the last video I showed the same puzzle being solved with a deep first approach. And tomorrow, sorry, the next video, we are going to pretty much put in practice all of this in actual code. So stay tuned for that. And well, until then, subscribe and hit the notification bell so you can know when I start to actually code the all this artificial intelligence. And not just that, but like this video if you like it in particular, or comment down below any ideas or thoughts you have about this. And I hope to see you tomorrow. Bye!